Today we discuss on pitchfork bifurcation. Pitchfork bifurcation is a particular type of local bifurcation where the system transitions from one fixed point to three fixed points. Here, system transitions from one fixed point to three fixed points. These are of two types, supercritical and subcritical pitchfork bifurcations. Consider the differential equation dx dt equal to rx minus x cube. R is the parameter and x is the state variable, that is the population density, and for fixed point or critical point we have dx dt equal to 0. So from dx dt equal to 0, so rx minus x cube equal to 0. So we get three roots, x equal to 0 and x equal to plus minus root over r. So there are three critical points, x1 star equals to 0 and x2 star, x3 star equal to plus root over r and x3 star equal to minus root over r. Now let f x r equal to rx minus x cube. Then del f del x equal to r minus 3x square. So find the value of del f del x for these critical points. Fx at the point 0, x1 star, put x equal to 0, so this equal to r, put del f del x, put x equal to root r for critical point x2 star, so put here r minus root over r whole square, so this equal to minus 2r. And third critical points, del f del x at third critical point root over minus root over r, so this equal to plus r, this is also minus 2r. If r is negative, the x is complex number when x equal to plus minus root r. So x equal to plus minus root r when r is negative, so x equal to complex number, x is complex number, so critical point complex number. So there is only one equilibrium point, stable point, one equilibrium point, x equal to 0, so r is negative, so del f del x at the point x equal to 0 is r is negative, so when r is negative, only one stable equilibrium point when r is negative, because other two critical points are complex numbers. And when r is positive, so 0 origin is unstable, because del f del x at the point 0 equal to r is positive, so this unstable equilibrium point, and two stable equilibria, x equal to plus minus root over r, and del f del x at the point root r equal to minus 2r, r is positive, so obviously this is negative, and f of x del f del x minus root over r, so put here value is minus root 2r, so 2 minus 2r, obviously negative. So there are two stable equilibria at x equal to plus root over r and x equal to minus root over r. Now we draw the phase portraits for r less than 0. So this graph of the curve y equal to rx minus x cube, y equal to rx minus x cube, y equal to rx minus x cube. This horizontal axis is x axis, vertical axis dx dt, that is actually this is equal to y rx minus x cube when r is negative. So we get this type of curve, and there is only critical point origin which is stable, because this dx dt is left hand side of the origin is dx dt is positive, so this right hand arrow, and this left hand side of the origin is negative, so this left hand arrow, so this attractor origin is attractor, so the origin is stable equilibrium point when r is negative. And when r equal to 0, the graph for y equal to rx minus x cube is this, and graph this also this stable equilibrium, origin is the stable equilibrium, r equal to 0. And for r is greater than 0, the graph is this, so this y equal to rx minus x cube, this graph is this, so this graph cuts x-axis at 3 points, this point, this point, this point, so this is equal to x1 star equal to 0, x1 star equal to 0, and x2 star equal to plus root over r, and x3 star equal to minus root over r. Obviously this is positive, dx dt positive, so put here right handed arrow, this dx dt negative, so put here left handed arrow, so this point x3 star is stable equilibrium, and x equal to x1 star equal to 0 is unstable equilibrium. This is the negative dx dt negative in the left hand side, so put here right hand arrow, and dx dt is positive, so this is the right hand arrow, put here right hand arrow, and so x1 star is a repulsive point, so this is the unstable equilibrium. And for the third equilibrium point is x2 star equal to root over r. For this dx dt is positive, so put here right handed arrow, and for dx dt is negative, so this is the left hand arrow, so this point x2 star equal to root over r is also is an attractor, so this is a stable equilibrium point. So we get for r greater than 0 we get 3 equilibria points, and only origin is unstable and other 2 equilibria are stable. Now we draw the bifurcation diagram when this is the horizontal axis is r, axis, and vertical axis is x axis. So when r is negative, we get only one critical point, x star equal to 0. So this is the x star equal to 0, this is the thick line x star equal to 0. So when r is negative, so we get only one stable point, stable equilibrium point, so this stable equilibrium point. So this thick line represents the stable equilibrium, collection of all stable equilibrium point for r less than 0. And these the bifurcation start at the point origin. So when r is positive, so there are 3 equilibria points. One is 0, and other is this point and this point, this point and this point. This point is this x1 star equals to 0, and this point 0, and this point x2 star equal to root over r, and for this point is x3 star equal to minus root over r. Obviously this 0 is unstable, so draw here dotted line this unstable branch for this unstable equilibrium points. And for particular value, positive value of r, we get 3 equilibria points for particular r, positive value of r, and one x2 star is positive, so this is, and also this is stable, so draw here arrow towards this branch. And also x3 star is minus root over is also stable branch equilibrium point. So this is an attractor, so put here and put arrow towards this branch. So one branch uh, changes to three branches, two of them two of them stable and one is unstable. This is the pitchfork pitchfork bifurcation diagram. This is the supercritical bifurcation. Supercritical pitchfork bifurcation, because this supercritical actually means that when R is positive, we get three branches from one branches, and as the bifurcation point origin 0 0, an exchange of stabilities takes place between two fixed points. The above type of bifurcation known as supercritical pitchfork bifurcation, because this bifurcation occurs for R greater than 0, R greater than 0. And other type of pitchfork bifurcation when we consider the differential equation dx dt equal to Rx plus x cube. And in the previous case we consider differential Rx minus x cube. Here we consider Rx plus x cube. So similar arguments for dx dt equal to 0 for critical points. Dx dt equal to 0 for critical points dx equal to 0, and this gives three roots: x1 star equal to 0 and x2 star and x3 star equal to plus minus root over minus r. And let fx equals to rx plus x cube, so del x equal to r minus 3 x square, and we get del x at the point 0 equal to r, del x at the point minus root over r equal to minus 2r, and also this equal to del x at the point minus root over r, and we get phase portraits. This horizontal axis is x, vertical axis is dx dt. So this graph represents y equal to rx plus x cube. This graph is this. So when r is negative, we get three equilibria. One is stable, origin is stable, and these other two equilibria are unstable. And when r equal to 0, we get only equilibrium point, which is origin, is stable, and for r greater than 0, we get the only one equilibrium point origin, which is also unstable. The bifurcation diagram is this: when r is negative, horizontal axis is r axis, vertical axis is x axis. When r is negative, we get for particular value of r negative, so we get three equilibria points. One is origin, which is stable, and other two is x1 x2 star equals to plus root over r plus root over minus r. This point is the x2 star root over of minus r, this point, and other critical point is this equal to minus root over of minus r, because r is negative, so root over of minus r is positive. So this point root over of minus r is unstable, obviously from this point unstable. So put here arrows away from this branch, and this unstable branch, for this unstable branch dotted line, put here dotted line for unstable branch, and this. So actually this graph is x square equal to minus r, and for the graph this is the unstable branch, and this is stable, and so put here solid line stable branch where x equals to 0, and after origin when r is positive, the only one equilibrium point which is x equal to 0, which is also unstable, So this is the subcritical pitchfork bifurcation, because this bifurcation occurs when r is negative. So this is the subcritical pitchfork bifurcation. Now here this is the supercritical bifurcation diagram. In the left hand side is supercritical bifurcation diagram, and right hand side is the phase portrait. This phase portrait, the horizontal axis is x axis and vertical axis is dx dt, which is fx, and this is the graph for y equal to rx plus x cube, and so this curve cuts the x-axis at 3 points. 3 points. This origin is unstable, and other 2 points, this the root over of minus root over minus r, and this is the plus root over minus r. This the points, 3 critical points, and when r is positive, when r equal to 1.3, when r equal to 1.3, and we get here this horizontal axis is r-axis for bifurcation diagram, and vertical axis is the x-axis, and for particular value of r equal to 1.3, we get 3 equilibria points. This point represents this point or this point, and this is the origin x equal to 0, and this point is represents this point corresponding to this point is a stable point, stable equilibrium. And when r going to 0, put r equal to 0, so we get here only one equilibrium point, and one equilibrium point r equal to 0, one equilibrium point is only point, one equilibrium point, and this is the stable equilibrium point. And when r is negative, we also, when r equal to minus 1.1, we get only one equilibrium point. Origin is the only one equilibrium point from his portrait, and for bifurcation diagram, for r is negative, we get only one equilibrium point. This is the one equilibrium point. And when r is negative, this one equilibrium point. When r is equal to 0, and bifurcation starts from r equal to 0, when r equal to 0, and when r is positive, we get 3 equilibria points. 2 of them are stable and one is unstable, and put here dotted line, red dotted line is unstable line, and other 2 equilibria are stable. For this supercritical bifurcation, this bifurcation is supercritical pitchfork bifurcation. This bifurcation likes pitchfork. This is the pitchfork. So this bifurcation pitchfork, and so we can say this type of bifurcation is called pitchfork bifurcation, supercritical bifurcation.